I'm going to talk about building information modeling level of development for facility management tasks. Here, the aim of this project is that to determine reliable information and appropriate information for the facility management to better make decision for the efficiency of the building performance. As you can see here, most of the cost is related to the operation and maintenance phase, not construction. So this shows the importance of the operation and maintenance phase, which is related to the facility management tasks. Currently, there are some software using for the facility management like BMS, IWMS, building management system, integrated workplace management system for the space management, for monitoring. And there are some other documents based on the paper format. The facility management try to use this kind of information separately. You can see this information is scattered, and there is no integration between the elements, between the information. Building information modeling has been emerging as a potential solution for this, to address this issue. Building information modeling can integrate all the information, all the software together. So it can be used for the facility management. Actually, building information modeling widely adopted to the design and construction phase in terms of visualization, clash detection, planning, cost estimation, and so on. But the problem is that, despite of the fact that we've got the benefit offered by BIM in the operation and maintenance phase, its utilization still remains significantly limited. Even if we've got a BIM model, we can transfer data from design and construction phase through the COBie format or data exchange or any other kind of standards into the operation and maintenance phase using for the FM system, facility management system. But why? Even we have the BIM model, or if we don't have a BIM model, why we don't use it for the operation and maintenance phase? The answer is information. We don't know which information do we really necessary to be included in a BIM model to use for the operation and maintenance phase, respect to the facility managers. So, when I'm talking about information, I mean information, geometric information, and semantic information. So, we need to find out which geometric information and semantic information do we really necessary to be included in a BIM model to execute FM tasks. In terms of geometric, when we talk about geometric, level of development pop up in our mind. When we say LOD 100, we just consider element just as a box, and LOD 400 with more details. So for us, it's important to know which kind of geometric information is necessary for the facility management or in the operation and maintenance phase. Because if we consider all the information for the LOD 400, the model is going to be too heavy, and we can't navigate that. So we should be careful about the geometric presentation in a BIM model. For example, look at this box. For us, I can include some semantic information in this box, but now it's a chiller. It's a chiller that's considered in LOD 100. But when we wanted to be in more detail, it's again the same chiller with LOD 200, and even more details, 400, that you can see the connection even between the chillers and so on. So If we wanted to have the LOD 400 for all of them, we couldn't make this better decision for that. So we need to know which geometric information is necessary for our purpose. More than this geometric information, as we are in the operation and maintenance phase, for us it's important to know the semantic information. As you can see here, in the design, construction, and operation and maintenance, in the first stage of the design, the graphics or geometric information is important for us. It's more important than semantic information. But in the operation and maintenance, we need just only a few geometric information and mostly semantic information. So what we did is define the building elements for our research, and we try to define the properties for each element with respect to the FM areas, using uniformat classification for the elements and using COBie OmniClass SPIE for the properties. Here you can see the example of each one. We can, for example, for the elements, we consider cassettes, which is taken from uniformat classification, and the properties that is necessary for us, which is taken from OmniClass, COBie, and SPIE. When I'm talking about properties, the properties could be all the semantic information, like warranties, date of acquisition, life expected, and so on. But what is really important, each element has their own specific properties. I mean, when I'm talking about fan coil, we need to know the fan efficiency, or we need to know about the filter and everything. So we find out which properties is allocated to which elements. With respect to FM areas, we define FM areas by conduct a survey in the previous paper that we published. These areas are the most important for ourselves: maintenance, space management, energy, security, assets, and safety management. And then we define the elements from uniformat classification. Obviously, it's not all the elements. But we create this Excel file with respect. You can see in the bottom, each element has their own properties with respect to the FM areas. So we try to find out which information is necessary to be included in a BIM model. Then we create a template in the Revit file using shared parameters. So this template can be used for the facility manager. And we find out more than 60% of the information is unnecessary. So it needs to be eliminated. And you can see the maintenance, space management in different areas of facility management, which requires different categories of the building. And we actually try to implement it in 2 buildings in our university. One of them is for academic, and one of them is for office. And we try to find out which information is available for our building to be included in a FM system. The point is, if we've got this template and we are looking for the new building, so obviously we can use it for the new building and we can transfer it through COBie. But imagine if the building has already built. In an existing building, if we've got a BIM model, we need to eliminate lots of information that can be used for the facility management activities. But if BIM not available, so we're going to model it from scratch. So this can be, again, use the template. So to conclude, this is a procedure for asset and facility managers. It helps to refuse heavy model. It's possible to capture data automatically and include, with respect, different facility management area. The future work would be data capturing techniques. Imagine we are talking about a building that is already built. So we already have some documents which is not updated. For example, we have as-built is not updated for ourselves. So we don't know what the elements, where it's going. For example, the elements is embedded in the wall. We don't know, for example, the pipe or in the ceiling. We have no idea where it's going. So we have some equipment like a laser scanning thermal camera that can be used for that, to find out the elements embedded in the wall or something else. But the point is, we need to find out which are the benefit and cost. If we want to consider that, we need to compare the benefit and cost if we want to get that information. Does it really worth to get that information or not? Does the advantage outweigh the disadvantage or not? And the big data, integrated the BIM model with extra information that I'm going to talk about it in thesis in 3 minutes. And that's it. Thank you very much for your attention.